Okay. So if you remember, we were talking about differentiation rules. Differentiation is the process that takes you from the given function to its derivative. Yes? And we learned about very simple ones. If I have a constant function, we learned that its derivative is equal to 0. And then we learned that if we have a x variable raised to a constant number, if I want to take the derivative of that, c goes down, and then you have x to power 1 less. And then I told you that these two are in the formula sheet, but these three are not. These are the consequences of this formula. But because they happen a lot, I would prefer to remember them separately. That's up to you. If you don't remember them, these are not given in the formula sheet, then you need to use this formula every time to be able to calculate these things. It's not a big deal. It's up to you. How do you want to do it? Okay. And then, if you remember, I gave you some examples related to this. So it is not that boring that you can think. You might think that, okay, this is a very simple function. Then I gave you some kind of problems that they are not in this form exactly, the functions that they are not exactly this form, but you can just transform them into this form and then start differentiation. Okay? Today I want to talk about 3 rules, which is, I don't know, for some reason, haven't discussed in the book at all, but they are using it. So let me just mention about that. And what are those? Are these rules. If I have a function, f, which is multiplied by a constant, this c is a constant. If I want to calculate the derivative of this combination, what I need to do, I just take the derivative of my function and just multiply it by this constant c. Okay? So it's not trivial, but this rule should be mentioned explicitly so that you can use that. So another rule that I want to talk about today is that what happens if I have the sum of 2 functions, it becomes a new function, then I want to take the derivative to differentiate the whole expression, f plus g. It is not trivial, but it turns out to be very natural operation. You can take the derivative of the first one, take the derivative of the second one, and when you found the derivatives, you can simply add them. Okay? These are used in the book without explicitly mentioning them. Okay? And the other one is, of course, for the subtraction difference of 2 functions. The same will happen. Okay? And there is no reason that this should be only 2 functions. It can be more than 2 functions, yes? Let me just mention exactly here. Please do not draw this analogy further. So if you think that if I multiply 2 functions, and if I want to take the derivative of the product of 2 functions, you might think, based on what the feeling that you get so far, you might think that the formula is the derivative of f, derivative of g, and multiply. Okay, so let me just mention that this is the wrong formula. You need to wait until Math 4 to learn what is the correct formula for the product. Okay, and the same thing for the division. If I have the fraction of functions, if you think that I can take the derivative of the numerator, the derivative of the denominator, and then divide them, that's also wrong. These two, the correct formulas here is a topic on in Math 4. But just I want to mention that only these rules are very natural. These rules are not natural. Okay, so the formulas are a little bit more complicated than what you see here. Okay, let us discuss about why these two formulas are correct, and then if you want to, you can just think about this one of yourself. So let us see why this formula is correct. So what is my goal? So my goal is to show this. Assume that I have a function h of x, which is c times f of x. My goal is to show that if I want to take the derivative of h, I don't need to do anything with c. I just take the derivative of the function f and just multiply it by c. That is what I want to show, that this is correct. Yes? Is that understandable, everything, what I'm saying? Yes? For example, here, if I ask you what is the derivative, I hope that you are following everything. Okay, so if I ask you what is the derivative of this function, what is your answer? 3x to the power of 2. Yes, exactly according to this rule. But now I am saying what happens if I ask you to calculate the derivative of this. You see, this is the same function I have multiplied by a constant. I want to show that this constant is not that important, yes? So you just keep the constant here and take the derivative of the function. And you know the derivative of the function, according to what Dylan said, is 3x squared. But now I have a 5 here, and then I multiply them, it becomes 15x squared. Okay? So the book is using it without explicitly mentioning it properly. Okay? So this is possible. If I have a multiplicative constant multiplied by my function, and I am interested to take the derivative of the whole function, it is easy. You can just simply ignore this for momentarily, just concentrate on the function, take the derivative of the function. When you are done, you go back and multiply that number inside. Yes? Just I want to show this is not a coincidence. It works all the time, every time. So if I have a function and I multiply it by any constant c, if I want to take the derivative of this combination, I don't need to be worried about this constant at all. I just take the derivative of the function and then multiply it by c. That's the goal. Yes? But if I want to give you the feeling why this is correct, I would say that, okay, I want to calculate the derivative. So let me change the name because h, I have used it somewhere else. So let me give this a name h. Instead of h, let me write it s. Because h is reserved for that formula in the derivative, yes? Okay, let us see why this is correct. If I want to calculate s prime of x, do you remember the formula? Do you cherish the soul of Leibniz and Newton? Yes. So what's the formula? Yes?
I think f of h.
No, because s, the name is s now. Okay, so it becomes s, yes?
Minus a.
No.
S of h minus a. Or, wait.
Okay. So you're studying really hard. Yes.
That's s of x minus h minus.
Why do you say minus?
It's plus. It's plus. Sorry, s of minus because of the other.
So let me.
S of x plus h and then minus s of x.
S?
Divided by h.
Exactly.
H goes to 0.
H goes to 0. Yes. Is that correct now? Everybody agrees? That's up to you if you want to have them in your memory, but really you need to appreciate it. So if we can actually overcome the coronavirus, it's because of these formulas, by the way. Yes. If these formulas were not there, we didn't have good microscopes, and then we were not able to do some research. Okay. So your life depends on this question that Leibniz asked. Yes, believe it. Yes. Okay. So it's better to remember it. Okay. Okay. So now what should I do? Can you help me continue more? So here there are ingredients that I need to feed in. Yes. These are just copy pasting parts. But s of x is clear. What is s of x? It is c times f of x. Agree? And this minus sign is minus sign, but I want your help for writing something appropriate for s of x plus h. You see, if I ask you what is s of 5, how do you answer? If you want to say something.
0.
No, s of 5.
Oh.
S of x, I don't know why don't you remember this. S is a function, x is the input. You put the input here, this function do something on it, give it out to you, yes? But how do you interpret this? If I put input here, x, this give it to another function, that function will apply on it. When it is done, it multiplies by c, yeah? So if I ask you what is s of 5, this 5 will be sent to f. F will act on it, gives you f of 5. After that, it is multiplied by c, and that is your output. Now I am asking you, what is s of 10? It becomes c times f of 10. Is that understandable? Yes or no?
Yes.
Okay, yes?
So it would be c times f of h plus x plus h.
Exactly. Agree? Is that understandable for everyone? Yes or no?
Yeah.
Is it strange? No. And now what you see a c is common, and in common I can factor it out. So what happens? This becomes the limit, c goes out, and then what is left for me here is f of x plus h minus f of x divided by h goes to 0. Agree? But now if I ask you, if you do not look this one, what is this part? What is this limit? Only this part. What is this? Yeah, dare to say, it doesn't matter if it's wrong. What is that one?
I think it's 1.
No,
Because
it's
it's
not
only f
1.
of x.
It's the definition of something else. So let me go back again. So if I ask you, do you remember the formula which is in the formula sheet for the function f? This is this formula. Do you remember this or not? That was the formula, the original formula, because here the name of my function was s, so I replaced the name f with name s. But I did this calculation, I reached to this point. So if I ask you what is the limit without this c, what is that one? Say something, please. What is that one? Yes, it is f prime of x. Isn't it clear? I have written it here for you, yes? This limit is equal to f prime of x. So this limit is f prime of x. And then I have a constant c multiplied by that. So it becomes c f prime of x. Yes? Coronavirus is affecting the brain or where? I hadn't heard about that. Okay. Might be they decide that the clothes will be off again. They have a press conference at 10 o'clock, yes? So the only important thing is that you shouldn't give up. I know the situation is not very good. Might be some of you are getting demotivated, but remember something. This is temporary. But if you, I don't know, if you feel weak, the effect will be forever for you. So I know this is hard, but you need to try to keep yourself in shape, yes? Even after 1 year, 2 years, it will pass. But if you, I don't know, somehow cannot overcome with the situation, the effect on you will be forever, okay? Because you don't know what will happen. So try not to get demotivated, yes? You can look at me and how motivated I am. I really don't care what's happening there. I'm just doing my own job, yes? Today I'm actually a cameraman these days, making videos. So you need to be actually happy, yes? I don't know. Might be you are more than happy now because you're not studying at all. Are you following what I am writing on a school stuff? Yeah, do you know what is a school stuff these days? Yeah, please go and read them because this is a little bit complicated. What I'm saying is that assume that you don't learn something this year, and for some reason you can pass, and the next year coronavirus probably has gone away, and then you start suffering from the derivative again. Or you might just want to give up math 4. But if it doesn't matter how you decide, it will affect your life for the future. Okay? So yeah, I don't know how do you want to keep yourself in shape. We can just be in touch together. Okay? So whenever you want to hear something, have you heard about this guy? I just remember I just saw this guy, Joe Dispenza. Do you know him? Yes? I don't know. Is it Z or H? I think it's very good. I didn't believe about these things before, meditation and things like that. But this is a neuroscientist, so he's a scientist actually. I think it's good to listen to him. Yeah, I usually listen to him when I'm coming to the school. So you need to find a way to cheat yourself, yes, to be happy. That's it. Okay. Okay, so might be we can listen to this together at some point, but yeah, let us finish this. Okay, now anyway, let me tell you that in the exam, I don't want you to really understand this. When I teach, I told you that I teach it completely for the people who really want to know everything at the level of the lesson that we want to talk. Now, if somebody asks you, if I have a product of a function by a constant, how should I take the derivative of the new expression? You can answer, you need to take the derivative of the function and then multiply it by the constant, yes? And then if somebody asks you why, and if you are that kind of person, care about why, this is the why. But if you don't care, that's up to you. You don't need to care. What you need to know is how to use the formula, okay? Because mathematics, if I just want to tell you, okay, this is the rule, just follow me, this is a little bit dictatorship, isn't it? So you need to know why. That's up to you if you really want to know why. But what I want you to learn is how to differentiate simple functions. Not very, very simple ones. It depends to the level of the question. But now we know this rule. Let me talk a little bit about this rule, okay? Hopefully now you are in better mood now. So let us see what we can do. Here, I want to show that the derivative of the sum of two functions is the derivative of the first one plus the derivative of the second one. So I would say that let us define a function s of x. This time, let me call it f of x plus g of x. What I want to show is that the derivative of s is equal to the derivative of f plus the derivative of g. Yes? This I want to show. Okay, now I want your help again, okay? So where should I start? I want to calculate s prime of x, yes? S prime of x is what? Is the limit of s of x plus h minus s of x divided by h goes to 0. Do you agree with me or not? Are you with me? Yes. Okay, now I want your help again. Exactly like the last time that you helped me, okay? So this time you help me more, okay? So here, h is h, but what can I write instead of s? For example, this minus sign is there. Let us do this. Yes, it's very good, by the way. You shouldn't see the big picture because it horrifies you. At least you can put the minus sign, you are relieved a little bit. Yes, I put the minus sign there. It's better than not putting it, okay? So we put the minus sign here, and then we start to see what can I do with s of x. S of x doesn't have any problem, unless you have a problem. So what is s of x? Yes?
F of x plus g of x.
X, okay. So if I write it and I ask you, do you agree with me this way of writing? Yes or no?
No.
Yes, you said no. Why no?
You need a parenthesis.
Exactly. Because if I write it in that way, this minus sign is only for f, but I mean the whole expression. It's crucial, okay? Now the hard part starts, okay? So let me open a little bit of a space here. So this limit, h goes to 0. Okay, now tell me, what can I put here? If you understand what I said there, it's just a matter of seconds to know what here. If not, I will explain it again, okay? But what can I write here? Someone else first? No one? Yes?
F of x plus h plus g of x plus h.
How many of you agree? How many of you agree? It's good, at least. Yes, good. That's correct. Because S of x is f of x plus h. X is my input. When I put the input here for s, the role is that this function is so lazy, sends this x to these two guys and say that you do them. And then you calculate f of x and g of x, and then we add them. Now we are sending x plus h as the input. Okay? So this s is acting like a king, yes? He actually doesn't do anything. He sends everything to f and g. Is that clear? Okay, now there is a simple algebra going in. I know that everyone knows, hopefully, how to remove this pair of brackets. Now, can you tell me what should I do? Please, everyone. Yeah, say something. What should I write? Everyone.
Minus 5 f of x
Yes?
minus g of x.
Okay, so Dylan is everyone. Talk about it, yes? You need to start, you need to do something for yourself, yes? So h goes to 0. Is that okay? Now, can you see what should I do? Can you be a little bit creative to see what I want to do next? Based on what I want to show. At least, you see, you know the copy-paste parts. It's better than nothing, yes? And then I have an h here. What should I do for the numerator? It's not that hard to see. The pattern of derivative should be familiar for your brain. Yes?
X.
Pardon?
Like factorize x.
No, x is not something that you can factor out. Be careful, you see, f of x plus g of x is different from f multiplied by x plus g multiplied by x. Yes? Here you can factor out. X is playing the role of the input of your function, so you don't know what will happen to your x when it enters your function. It might be a complicated function. So x is not free to move around. Do you have this feeling? Yes, okay. So the factoring doesn't work. Next idea. What's the next idea? Just say something. If it is wrong, we can correct it. The next idea is because you see you want to have something about the derivative of f. Again, might be you cannot remember the formulas. So do you remember what is f prime of x? Just tell me. Just tell me, what is f prime of x? It is the limit
F of x plus h
yes,
minus f of
thank you very much, divided by h. So this part is f prime of x. This is the scratch paper. Now what is g prime of x? Can you just say it to me again?
g of x plus h
Yes.
minus g of x divided by
So this is the active way of learning mathematics. Yes. So it means that I write my definition, I come up to here, then I get stuck. When I get stuck, I need to find a way out of it. So I go to what I want to show. I want to show this is f prime plus g prime. I don't know how to connect it. I go to a scratch paper. I write the formula for f prime. I write the formula for g prime. Might be this will be, this might give you some hint how to do that. Now, do you see what I should do or not? So you see here for f prime, you have these two next to each other. Yes? For g prime, you have these two next to each other. Yes?
Oh, you group.
You group them. As simple as that. Yes? So it means that I write this one first, and then I write minus this one next to it. I take it and put it next to it, and then I put this one next to it. Is that right? Yes? And then it becomes clear there is only one step left. Can you help me to do that?
You replace them.
I would say I would divide this one by h, this one by h individually. Because this is possible. Yes, if I have a plus b divided by c, do you agree I can write it a over c plus b over c? Yes? Because if I have this fraction plus this fraction, the common denominator is c, I just simply add them. Yes? So this is possible. So I can write it in this form. I can write it the limit of this one divided by h plus the other one divided by h. Yes? H goes to 0. But then, can you see what's happening? What is this? The limit of this part is? The limit of this part is?
F prime.
The limit of the second part is g prime. And what is the sign between them? Addition. So this becomes f prime of x plus g prime of x. So it means that the derivative of the sum of two functions is the sum of the derivatives of individual functions. Is that clear? The same is true for subtraction. If you are interested, you can do the subtraction yourself. Okay? But now, these rules, I will add them. This is also given, I think, in the formula sheet. I don't remember exactly. For Math 4, I remember it's given. Probably it's also given for you. So let me write them here. These are the formulas for different functions, but these are completely generic rules. If I have a constant multiplied, let me emphasize, everything that you see here, C is a constant. Yes? So the derivative of this one, what can I write in front? It becomes C times F prime. What is Fg plus F? What is F plus G prime? It's F prime plus G prime. And what is F minus G prime? It's F prime minus G. Yes? So these are three generic rules. It doesn't matter what the function is. If the function complicated, simple, it doesn't care. These are for every function. These are correct for every function. But this formula is only valid for this function. This formula is only valid for this function. These are particular functions. These are generic rules. Yes? Now I just want to, today, I want to solve some examples for you. But I want you to be engaged with me, okay? So because otherwise you will not learn. So let me clean everything. This example that I am writing here is very important for the exam. And I say very important. I know that might be most of you only care about the exam. So I'm just looking it through your eyes. Very important means that exam question, yes? Yeah. I need to use my tricks so that you should pay attention to that, yes? The only thing that I don't care is probably the exam, okay? Yeah, you shouldn't care about these things so much. You should care about enjoying your life, yes? Mathematics for me is what a way to enjoy life, okay? You need to find your own way. So, let us start this example. But by the way, this is a very important example. So let me simply write differentiate. Can you tell me what is the meaning? This is an English word. I haven't seen it in Swedish books. So what does it mean, differentiate? Yes, exactly. Thank you very much. Find the derivative. Yes? So let me write functions for you here. So number one. F of x is equal to 3x to power 5. Let us start with this simple one. I write every detail here, but in the exam, if you can do it in your head and just write the answer, it's better. Okay? So, but I want you to understand you are using these rules. So if you don't mind, let me give them numbers so that I can mention what I am using. Number 1, number 2, number 3. Okay, so if I ask you what is the derivative of this function, you need to think in this way. The goal is to calculate the derivative of this function, yes? Then I have to use rule number 1. Why? Because I see a constant number is multiplied by a function. According to rule number 1, so let me write it on top. According to rule number 1, I don't care about this constant. I just take the derivative of my function. Yes? So the next step, you need to continue until there is no track of prime left. Everything is gone. So this 3 is here. But for this one, which formula should I use? These are not important here for this particular case. This is important. And how should I act? This exponent goes down, and then I need to subtract 1 unit from the exponent. Yes? So this exponent, which is 5, goes down, and then I would write x to power 4. Everybody agrees? But then nobody writes 3 here, 5 there. We can simply write 15x squared. So in the exam, I really want you to, when I ask you, you just write the answer. Okay? Do these processes in your head. But you need to understand that 2 things are used. One of them is rule number 1. The other one is the formula from the table. If you understand this, you are on the safe side. The reason that I emphasize on this, because I am also seeing what happens in Math 4. If you do not learn it in that way, then in Math 4, you will have a lot of problems. Okay? So you need to understand the process, even though I only care about the answer at the end for these simple ones. Okay? So let me go to another problem. Number 2. F of x equals to, let me make it like this. 2x to the 3 plus 2x to, let me change the numbers all the time. 5x to 6 plus square root of 2. We want to take the differentiate this one. Again, I write it in complete form, but it is better. It's very, very simple. I know that after just 1-2 examples, you can do it in your head. And please do that in your head whenever you have, when you can do that. So if I want to take the derivative of this, the way that I think about the problem is this. Do you mind if I change this one to negative? Because I want to have a combination of positive and negative one. It doesn't matter actually. So here, f prime of x that is wanted in the problem is the derivative of the whole expression. 2x to the 3 plus 5x to the 6 minus square root of 2 prime. But you see that this function in its entirety is not in my table. So it means that I cannot answer it unless I can use these rules to decompose this a little bit complicated function to the derivative of simple individual functions. Yes? So what I can do, I can see that this is the sum and difference of 3 parts, 3 functions. According to rule number 2 and number 3, according to rule number 2 and 3, let me write it in that way. Number 2 and 3, what I can write is this. Is the derivative of the first part, because the next one is plus the derivative of the second part minus the derivative of the third part. Yes, this is the first thing that you need to know. I have to use rule number 2 and rule number 3 to be able to write that. Any questions so far? Okay, now which rule should be applied from now on? Which rule?
1.
Rule number 1, yes? Because now this is the product between a number and a function, the product of a number and a function. For this one, I can use something extra. We can come back to that. So let me continue. So then it becomes rule number 1. Rule number 1 is 2, the derivative of x3 prime. And then I have plus 5, the derivative of x6 prime. And then I have minus, let me keep it for the time being. Is that understandable for everyone? So you see, all these rules play a role. 2, 3, and number 1. And now I am allowed to use the table. Because the primes are now on the functions that I have them in my table. Yes? So now help me to write it down. 2 is just a constant. What is the derivative of x to the 3? I can use this rule from the table. What's the answer?
3x squared.
3x squared, thank you. And then plus 5, the other one? Yes, everyone. 6x
To the power of 5.
5. And this one,
Minus 0.
minus 0. Because minus is minus. The square root of 2 follows this rule. It's a constant. Any constant, the derivative is 0. And now nobody leaves this like that because I can write it simpler. What's the answer? 6x squared plus 30x5. That is your derivative. The final product is called the derivative. The process to reach there is called differentiation. Yes? Is that clear? But even I'm completely sure after 2 or 3 examples, you can just immediately write the answer, which is better. Yes? So if I give you this, if you just immediately write this for me, I accept it, but I want you to really understand what is going on. Okay? The rules are being employed here. Is that clear? So let us improve the level of the problem. So this is so polynomial functions you don't have any problem with. Okay, so number 3. Let me increase the level a little bit. Okay, so what happens for this function? F of x is x to the 3. Let me write 2x to the 3. Let me start with the simpler one. Okay, so what do you think about this? This is a little bit x squared divided by 2. A simple one, but very important one. The things that I emphasize, very important one, is coming from my experience. I have seen that people make mistakes because in these simple ones. So how should I take the derivative of this? The first impression might be this. I don't know how to do this because I don't know the formula for division. Yes, somehow you are right. This is the fraction. And I told you that the rule for fraction is in math 4. But this is, even though it is written in the form of a fraction, but you can change the form of the fraction into a form of a product. Yes, this is one of those fractions. Can you say, what should I do here?
0.5x to the 2.
0.5. So let me change it to 3. Okay, now what do you say?
1 over 3.
Yeah, that's better. Yeah, that's better. 1 over 3. Now, okay, thank you. So sometimes, if the questions are type this, these are level 1 problems. But if the function has a different form and your duty is to change the form of a function into an appropriate form and then start differentiation, that would be a higher level. Yes? For example, this function, even though it's very simple, but if you do not understand to write this as 1/3 of x squared, then you cannot do it. So first of all, I want to make sure, do you understand that these two things are the same? Yes? And now why this is good? Because if I ask you, what is this? You would say this is playing the role of the constant c. Yes? Because it's a multiplicative constant. Yes? A constant multiplied by the function, and I want to find its derivative. Yes? So what I should do like this. This is the first step. I write it in this form, and then I take the derivative. The derivative is 1 over 3x squared prime. And now I use rule number 1. I take 1 over 3 out because that's a constant, multiplicative constant, and I just concentrate to take the derivative of this. But what is the derivative of x squared? 2x. But nobody writes it in that ugly way. People write it as 2/3 over x, or if you want, you can write 2x divided by 3. It doesn't matter. I prefer that one, okay? It doesn't matter. So that is the derivative. So remember, sometimes you need to change how the function looks, make it similar to the rules that you know, and then apply the rules. So this part we want to practice now. Yes?
Can't you just, the x squared part, just use x to the power c and then replace that?
Yes, you can do that, but you need to understand this. If you think in this way, but do it in your head quickly, that's okay. If I give you this and you write the answer here, that's okay. But for example, if I give you this, what do you want to do here? It's different. I'm trying to practice here, okay? Because if I ask you this question, x squared, instead of 3, I can write 3x plus 1. This you cannot do. You need to wait until Mat 4. Okay, so it's very important to understand that even though this is a fraction, but this is one of those type of fractions that can be written as a product. If I want to write this fraction as a product, there is only one way. Bring the whole thing up and make it -1. And then the problem is that this is again a product rule. This is also Mat 4 lesson. So be careful. Only these type of fractions that can be transformed into some product with constant number, you can do it at this stage. And there are high-level questions in the book are of this type. I just want to practice here. Is that clear? Okay. Okay, now let us go to number 4. You need to learn the problem just right here, okay? So number 4, let me give you another function. So f of x is equal to, what do you think about this? X to the power of 2. So let me write it with blue. X to the power of 2. Let me write it with a 2. 2x to the power of 2 multiplied by x squared plus 1 to power 2. We want to differentiate this. So I want to show that the problem is not that boring, yes? You might say that, okay, I have only one formula, so the diversity of problems that I can solve is very limited. Yes, it is limited, but not that much that you might think. So you can also take the derivative of this function. How? Can I immediately start differentiation? You see, this formula in this function in this form is not in my table. I am not allowed to start differentiation until I write it as a combination of functions and of those type of functions. So what is the first step that you need to do? Yes?
Put like the exponent. You have to expand.
Expand. Because you see, be careful. The priority is with the power. You are not allowed to multiply x inside. You have to expand and then multiply. Yes, that's correct. So you see, here I cannot start differentiation right away. I have to think a little bit to change the form of the function into an appropriate form, then I start differentiating. So what happens? F of x is equal to 2x squared. Then what happens? This one goes up. So sorry, the first one to the 2 is x to the 4. 2 times the first one times the second one is 2x squared. The second one to the 2 is 1. Agree? But still, it is not enough because this is a product and you don't know the rule for product. So if it is product, you need to wait. But there is a way out of it. What can I do? I can multiply it inside. Yes? So this, you see, I haven't started. This is why chapter 1 was very important, because you have to learn to simplify sometimes. Okay, so I multiply this. What's the answer? 2x to the 6, and then plus 4x to the 4, plus 2x to the 2. Now everything is ready. You can start right here. You cannot not start from the beginning. You can start from here. But I want to test your understanding. Can you just drop all the intermediate steps? Just give me the answer. I think you can do that. Okay? What is the answer if I want to do it? In principle, you need to think in this way. Take this one, take this one, take this one separately by rule 2. And then take these 2, 4, and 2 out by rule number 1. And then concentrate on differentiating these one by the formula here in the table. Yes? But immediately you can do all of it in your head. Can you tell me at least? What's the first one? Do it in your head. Yes, just say it.
12x.
12, get to everyone. 12. 6 goes down and will be multiplied by this 2. It gives me 12. And what would be the exponent now? 1 unit less. It's 5. So don't waste the time. After you fully understood what you are doing, you don't need to waste the time. Okay, and then what we do, go to the next one. 4 goes down, but there's another 4 here. They all multiply. It becomes 16. What would be the exponent? 3. And the next one?
4x.
4x. So this is the derivative. So you see, most part was not differentiation. Most part was simplification. So this is why I spend a lot of time on chapter 1. Okay. Now let me give you another example. Number 5. F of x equals to, let me see what is your opinion about this. I don't know, I think I gave some of these type of examples before because that is possible. So let me review this at least. You want to take the derivative of this function. So what should I do here? Can I immediately start differentiation? No, because this function that you see is not of the type that you immediately see in your table. So you need to change the form in a way that it is similar to one of those forms. So what is your suggestion here? Do you feel the difference? The example that actually Dennis told me how to solve, the variable was in the numerator. I don't remember exactly what. Yeah, it was, I think, something x to the power of 2 divided by 3, something like this. The main difference between the previous problem and this problem is a crucial one. Here, the constant is in the denominator. The variable is in the numerator. So you need to remember these small tricks. Here, the variable is in the denominator, the constant is in the numerator, and you will see that the solution here will be different from the solution here. So these are skills, these are different from understanding. So somehow it depends to your memory. You understand it here, if you don't repeat it, you will forget about it. Okay, now do you have any suggestions? Anyone else? So just tell me what to do, I will continue doing it. Yes, you know?
1 over x to the 4 times.
Okay, so you are saying that write it in that way. Then what? Because now you succeeded one level, because now you have written it in a product form where this number constant c is 3. I agree with you. But unfortunately, this function is not exactly the form that you see there. And you just continue.
You can use the first rule.
The first rule for this combination, it gives you this, and then it will be this one. But then I have to continue somehow because the prime is still left. How should I do? Because this, you don't see this in this table. You see it only for 1 over x. This is 1 over x to the 4. So what should I do? Can you say?
No, I'm not sure.
Yes, Jonathan?
You should take it to the -1, so you get
-4, you mean?
yes, so you get
Yeah, that's the idea, yes? So I bring this up and make it negative. Yes, and then take the prime. But this is exactly of this form. If I ask you, if you compare this one with that one, you immediately realize that c is the constant -4. Okay, so let me start writing it here. So if I want to do this, the first thing that I do, I change the form of the function. If you want, you can write it as 3 times 1 over x to the 4. And then what I do, I bring x to the 4 up. So I have a constant 3 here. X to the 4 goes up, it becomes x to the -4. Everybody happy with this one? Yes? You know that if I have a so this is the definition of negative exponent. Yes? It becomes 1 over x to the 4. Now I start differentiating. So let me just write everything down, even though you can do this part in your head. So I now use rule number 1. 3 goes away, and then I have minus x to the 4 prime. But the next step is this formula. Yes? So 3 is there. What goes up? -4 goes down. And x to power, can you say x to power what? -5, because -4 minus 1 is -5. And of course, nobody leaves this like that. 3 times -4 is -12, x to the power of -5. If you stop here, that's completely acceptable for me. But myself prefer to write it with positive powers. I continue one more step. So I would write minus, I write 12, and I take this one down to make it positive. But you stop here, that's okay. Is it clear? Yes? Okay. Another type of example that I really want you to understand is that I want to make the fraction a little bit more complicated. But I cannot add terms to the denominator. Remember that. If I add terms to the denominator, you need to wait until math 4. But I can add any number of terms to the numerator, and still you can solve it. And usually these are higher level problems. So let me just write number 6 here. So number 6, I have f of x. Let me start with a little bit simpler one. So let me write x squared in the denominator, one term. And let me write 2 terms, for example, in the numerator. 5x to the 3 plus 2x squared. So remember this, I can only give you this type of function, this type of fractions in the exam. It means that this is a fraction. The denominator consists of one term, but the numerator can consist of whatever you like, any number of terms you like. So be careful about this type. In this case, you need to use this formula. If I have a plus or minus b plus or minus c plus or minus etc. divided by d, you can always decompose this fraction into a sum or difference of a number of fractions. You can divide individually. You can divide a by d plus or minus b by d plus or minus, depending it is plus or minus. So c over d, and then you continue. So this is something that, of course, you know that, yes, because if I want to calculate this, the denominators are all d, so I take the common denominator to be d, and I add or subtract the numerators corresponding. So this is the idea. This is not in the formula sheet. This is based on what you know about fractions. So now, the first thing that you need to do here is just using this rule. So I write this one, the first one, divided by the first one, plus the second one divided by the second. Okay, I want to wait. Everybody understands what I'm doing here? Okay, so you see, it is something like teaching you how to solve a puzzle. So there are patterns that you need to keep in your mind, okay? These are the examples that I am mentioning here are some patterns for you, okay? So you need to remember them. If you don't remember them, I might say it might be a little bit hard in the exam. You want to rediscover everything again. But what can I do here? I can simplify the way that we learned in chapter 1. Instead of this one, 2 of these x's and 2 of them are gone. So what is left? 5x over 1, which I don't write. What is the next one? This is 2. And then this is a very simple one. Now, can you tell me what is the derivative?
I have a question.
Yes.
Why would you not just factor x2 out?
That was a stupid question. When I was doing it, I realized it is better. Yes, you are right. I can factor it out and then cancel it. Okay. So let us prevent this stupidity. Okay. So let me add 1 to it. Yes, you are right. That was a better solution. Okay. So you caught me. Okay. Then it becomes harder. So that is, if you don't mind, let us keep it in that way. That would be the next example. Yes. But you are right. In this particular case, what Dennis says is much easier because I factor x squared and that x squared and that x squared are gone. Okay. Yeah, thank you. This is better. But now what I can write here. Can you tell me what is f prime now? Just quickly. Yes, Ruben?
7.
No. Be careful. It's not 7. What's the derivative? What? 5. Yes, because if you see, let me just write everything. So you say that the derivative of f here is 5x plus 2 prime. Yes, it becomes the derivative of the first part plus the derivative of the second part. But here, this is rule number 2. Now I use rule number 1. 5 goes out, and then I want to take the derivative of x. and then the derivative of 2. Now tell me, what is the derivative of x? You have it in the table. It's what? 1. What is the derivative of 2? It's 0. So it becomes 5 times 1 plus 0, not plus 2. So the answer is 5. So the derivative of f is just simply 5. Is that clear? Yes or no?
Yes.
Okay. So now let me increase the level a little bit. But yes, in this case, I would say that that method was much easier to factor x squared and just simply cancel. But sometimes we cannot cancel. So let me give you this example. Number 7. F of x is equal to, for example, 7x to the 4 minus 3x to the 2 plus 5 divided by, so let us make it x to the 6. Okay. Let us make it x to the 3. Okay. Here, nothing you can simplify because you cannot factor anything in the numerator. But how should you realize this is this lesson? Because you have a fraction, you have some terms in the numerator, but you have only one single term in the denominator. When you have only one single term in the denominator, you need to remember this trick. Okay, now can you tell me what I should do first? What is the first step? The first step is not differentiating. The first step is using this idea. So be patient. Just do the calculations very patiently. So 7x to the 4 divided by x to the 3. And then minus, because there is a negative sign, 3x squared divided by x to the 3. And then plus 5 divided by x to the 3. So do you understand this part? This part is according to this form. But still, I can simplify a lot. So let me simplify as much as possible. Okay, just tell me, what can I write instead of this, everyone? 7x to the 4, just forget about whatever is coming. Just concentrate. It is what? 7x. Okay, minus, what do you think about the second one? 3? Sorry? 3 over x, yes, you mean? Because now 2x's in the numerator and 2x's in the denominator are cancelled. 1x is left in the denominator. Yes? And then this we cannot simplify anymore. But it is not still good, yes? This one is good. I don't have any problem with this part. But this one, let me write it with negative powers. So this becomes 7x. I need to bring it up. It becomes minus 3x to power minus 1. The next one is 5x to power minus 3. Do you agree? So you see, one thing is very important. I am not simplifying anything. I cannot say that this is simpler than that. I am not simplifying. I am writing it in a different form so that I can use the formulas that I have. That is my goal. The goal is not simplification. Might be, for example, in this case, yes, this was more simplified than this. But in this case, I wouldn't say that this is much simpler than that, because it involves negative powers. But do you think that this is exactly in the right shape that I can start differentiation here? It's completely clear, yes? Help me to do that. Can you tell me what should I do? This is the difference and the sum. So I need to concentrate only here, here, and there individually. So let us concentrate on this one. Can you tell me immediately what is the derivative of 7x? 7. Yes? So I would write 7. Okay, now what should I do here? You can do it still in your head. This minus 1 should go down. Minus 1 goes down, will be multiplied by this negative 3. It becomes positive 3, and the exponent becomes 1 less. The exponent is already negative 1. If you take 1 from it, what is left? Negative 2. And then this one. Minus 3 goes down, it becomes minus 15. And x to the power of minus 4. I said, if you stop here, that's okay. But if you want, for example, in this case, it depends on the problem that you're considering. So if I want to make it positive, it is not necessary, but I prefer to write it in positive powers. I bring it back to the denominator, make it positive 2, and minus 15 divided by x to the power of 4, because usually working with positive powers is easier for our brain, yes? We get used to this from more elementary grades. Any questions? Is that clear? Now let me make it a little bit more challenging for you, and now I want to wait for you. Okay, I will give you this type of example. So if you can, I would say that if you can finalize this problem on your own, it means that you don't have any problem from the previous session and this session. But there's also 2 things left. That is understanding the definition of the derivative and finding the slope. I will come back to them, okay? But for the time being, you are on the safe side if you can solve this example for me. So number 8, let me make it in this form. F of x is equal to, so let me write 2x squared plus square root of x divided by, let me write 1 here, and then let me write the third root of x here. Okay, if you can solve this problem, I'm not saying that this is, it doesn't mean if you cannot solve this, you will fail, no. If you can solve this, you are on the safe side. This is not an if and only if, yes? If you can solve, you are on the safe side. It doesn't mean that if you cannot solve, you are failing, yes? I want to wait a little bit for you, okay? Yeah, I think 5-6 minutes is good. Try to do everything patiently. And if you have forgotten, unfortunately, these formulas, let me write them for you. So if I have this, the nth root of a, do you remember? It's a to power 1 over n. And when n is not written, by convention is what? 2. Yes? So these formulas will be needed for this problem. you finish? Let's see. I don't know the one that's I just want to see the list.
Usually second.
Oh, that's good. It's better always to skip. Yeah, it seems quite right. Good. So you're on the safe side. Yeah, it's good. So you need to continue.
Oh.
It's correct. So so these are three terms, so it's only one term. So the method is to divide them separately. Yes, this one, this divided by this one, this one. And then I have written two formulas there. You can use them. And of course, I didn't mention them, but you know these formulas, yes? So if I have a to power m divided by a to power n, what can I write? M minus n. That is also necessary. And if I have 1 divided by a to power n, you can write it as a to power minus n. So these are also something that I thought that you might know. But these are also in the formula sheet, unfortunately. Yes. Yes, but then 2, and this is the formula that I just wrote. Yes, you see, x to power 2 divided by x to power 1 over 3, so it becomes x to power 2 minus 1 over 3, and then you calculate 2 minus 1 over 3. Yes? Your question? Two more minutes, okay? Should I start solving it now? Yes? Okay, so let me do this. The first thing that I do, I realize that this is not in my table, so I have to change the form of the function. Now I have a lot of experience now. I see that I have a fraction, and I have one single term in the denominator, so the trick is using that formula. So the first thing that you do is to write 2x squared and then divide it by the third root of x. Yes? The next one is all positive, so you write square root of x divided by the third root of x. And the next one is 1 divided by the third root of x. So the calculation is a little bit long here, but this is simple. So the next step is just focus on one term. But x squared doesn't have any problem for me. This is just 2x squared. But then what can I do based on your previous example? If you just check the video again, you see that I solved some problems of this type for you. So you know that I need to use this formula. So here 3 is, I can write it as x to power 1 over 3. Understandable for everyone? Yes? I go to the next step. Square root of x is that guy, but instead of a, I have x. And then again, this is x to the power of 1 over 3. And then again, the same scenario here. Yes? And now what I do, I just write it. I need to still simplify each expression. So here, this 2 is just a factor, so just pull it out. So this becomes 2. But this I know what to do. This part. Yes? What should I write? I need to write the x. According to this formula, I need to subtract these two numbers. If you can do it in your head, do it. Otherwise, use your calculator, or you just go to scratch paper, calculate 2 minus 1 over 3. I hope that you don't have problem here. The answer is what? 5 over 3. Yes? If you have problems, you can ask me. But here, if you don't have any problem, I can just simply write 5 over 3. So the answer, instead of this, I can write that. Here, the same story. I go to scratch paper. I have 1 over 2 minus 1 over 3. The answer is 1 over 6 by common denominator. So the answer becomes plus x to power 1 over 6. Here, I cannot do anything except using this fact. So I bring this up and make this one negative 1 over 3. So now tell me, was it hard? Is that understandable for everyone? Yes? Now everything is ready. In this case, my c, constant c, is 5 over 3. Good. In this case, my constant c is 1 over 6. And in the last case, my constant c is negative 1 over 3. So I can use the formula now for each one of them. So now I start differentiation here. Again, do most of it in your head. So I have the sum. I need to break it into individual pieces. I have a product. I take 2 out. So do it in your head. What goes down here? What goes down here? 5 over 3. And then if you cannot do it in your head, you can write it patiently and then use your calculator. You shouldn't be in hurry. Okay, and then what happens here? 1 over 6 goes down. And then you write 1 over 6 minus 1. So if you don't mind, let me clean this. And then here, plus minus 1 over 3 goes down. And x to power minus 1 over 3 minus 1. And then let us simplify this a little bit more. 2 multiplied by 5 over 3 is 10 over 3. And then can you do it in your head? What is 5 over 3 minus 1? 2 over 3. Because 1 is 3 over 3. 5 minus 3 is 2. So it becomes 2 over 3. And then what happens here? It is plus 1 over 6. X to power what?
Minus 5 over 6.
Yes, because another name for 1 is 6 over 6. 1 over 6 minus 6 over 6 is minus 5 over 6. And then plus minus is not minus at the end, a third. X to power minus a third minus 1 is minus 4 over 3. So that is your answer. You can stop there. How many of you got exactly these numbers right? Yeah, good. How many of you were on track, actually? That's good. So it means that this is probably the hardest differentiation at your level. Okay, so it means that you are on the safe side if you understand at least what's going on. Are you tired or not? It means yes. Okay, so I stop here. But no, let me tell you one example. Very simple example. I just want to tell you very simple example. What do you do this one? Because if I give you this very simple function, and I ask you to calculate f prime of 2. I just see this simple example and I end. So do you remember, so far, this is a little bit different here. You see, this is not f prime of x, it's f prime of a number. Can you tell me what I should do? One way is to go to this long limit process. Do you remember? Which is very lengthy in this case, because this is power 5. Another way we'll learn just now, because we know the formulas for differentiation. If you want to calculate f prime of x, these are the rules we practiced. If you want to calculate f prime at a given number, you need to do everything that you learned here, but at the end, you need to replace x with that value. Yes? So if I want to answer this question mark, for the time being, I don't care about it. I just take the derivative. What is the derivative? Can you tell me? It is 5x to the 4. Here it is not finished. One more step is to write f prime of 2 is equal to replace x with 2. So it becomes 5 times 2 to power 4. 2 to power 4 is 16 times 5 is 80. That's the answer. And if you go through this long process of taking that limit, for this one, it is quite lengthy. But if you really are patient and do all those calculations, the answer becomes 80. So you see that this is very simple calculation. I will emphasize next time on these two problems. And on Friday, let me end this stream. On Friday, Morten asked me to help him in the exam.